Hi everyone. So we are doing H4 today, which is probability part 1. So what are we going to see is the introduction to probability first. So the definitions are sample space and probability of event occurring. Sample space is all possible outcomes. Example, you roll a unbiased die. Sample space can be any one of the digits can come on the face of the die, which is 1, 2, 3, 4, 5 or 6. So you roll an unbiased die, the sample space will be 6. So probability of event occurring can be defined as number of favorable outcomes divided by sample space. So sample space is all possible outcomes. You need to divide with that, and favorable outcomes is what you will need to figure out from the question. So using this formula, one simple example, probability of getting a 5 while rolling an unbiased die. So getting a 5 becomes your favorable outcome. And obviously, you know, getting a 5, there is just one possibility of that. And hence, in the numerator, we have written 1 divided by the sample space. Sample space in case of an rolling of an unbiased die, you know already it is 6. So probability of getting a 5 while rolling an unbiased die is, the answer to that is 1 by 6. Now, using this, let's solve this question. A group of 3 people has to be shortlisted among the 4 people A, B, C, D for distributing the first, second, and the third prize, 1 to each person. What is the probability that B is the part of the group? If you exactly remember, this is the same question that we had done, but in that case, we had to just figure out the number of ways in which the prizes has to be distributed. But here we are going to figure out the probability, and the favorable outcome is that B has to be the part of the group. So first of all, sample space, you remember selecting 3 people out of 4 people, 4 ways of doing that, rejecting one person every time, 4C3 or 4C1 also you can now call it, since you already have the ideas of NCR, NPR, and then distributing the first, second, and the third prizes between the 3 different people. There are 6 total ways. So sample space is 6 into 4, which is 24. And now comes the important part, which is the favorable outcome. That the favorable outcome is B is the part of the group, and B is the part of the group. That means the one scenario out of the 4 scenario where B is not part of the group, that is third scenario, we are going to ignore that. And the remaining 3 we are going to consider, because those 3 scenarios are where B is the part of the group which satisfies our restriction. So B is the part of the group, 3 scenarios, and each of the way obviously we'll again have 6 ways of distributing the first, second, and third prizes. So favorable outcome is 6 3s are 18, and the probability is favorable outcome divided by sample space, that is 18 upon 24. You solve that, you get 3 by 4 as your answer. So 3 by 4 is your probability. This is how you apply the formula of probability to the different questions. So obviously, now whatever you have done so far based on permutation combination will also be coming into the picture, and then you are going to do an additional working of figuring out the probability part as well. The next one, a team of 11 players needs to be shortlisted from a group of 15 players. Assuming B is the part of the 15 players, what is the probability that B is also the part of the team? So 11 players has to be selected out of 15. So 15C11 becomes your sample space, but you are not going to do that, you know already. You are going to use 15C4 for the mathematical ease of calculation. And the favorable outcome is B is also the part of the group. So B is selected. The remaining 10 people are supposed to be selected out of the remaining 14 people, because B is already selected, because that is the favorable outcome. So your favorable outcome is, ideally, assuming B is already selected, that remaining 10 people from the 14 players. So 10 players from the 14 players, 14C10, mathematically you are going to do 14C4. So when you do 14C4, the answer that you get is this. And the question is, find out the probability. Probability you already know, favorable outcome divided by sample space. You do that, this is what your answer is, 1001 divided by 1365. So both things now we are combining, not only the calculation ease but also the basic idea of probability.
So let's move to the first question. Now over here there are four cities given to us. So A, B, C, and D are the four cities that we have. H, I, J, K, P, Q, R, V, W, X, Y, Z are the routes connecting these cities. The first question says find the probability that a route from A to D will pass through P or through V. Now we have to find the probability that a route from A to D will pass through P or V. That means it's basically probability of A union B. So what we'll do is first we'll find out the route passing through P, not V, that is only through P part. So only through P is 4 into 1 into 4. That is A to B there are 4 routes, B to C there is only 1, and C to D there are 4, as we are not considering V. So that's 16. Now only through V but not through P there are 4 into 2, because we are only passing through V but not through P. 4 into 2 into 1, that is 8. And now let's calculate through both P and V. So if both P and V, that means we just have to consider P and V. So 4 from A to B, B to C there's 1, C to D there's 1. So 4 into 1, that's 4. And the formula for this is P naught V plus V naught P plus both P and V, that is 16 plus 8 plus 4, which is equal to 28. As its probability, we have to consider the sample space also. Sample space is all possibilities from A to D. So there are 60 routes from A to D. So probability is 28 upon 60, that is 7 by 15. So option 1 is the answer. Moving to the next question. Find the probability that a route from A to D will not pass through R. From A to D will not pass through R. That means not through R is what we are going to consider. So not through R will be 4, A to B, B to C 2, C to D 5. So 4 into 2 into 5, that's 40. Sample space is 60, so 40 upon 60, which is 2 by 3. So 2 by 3 is the answer. Now we can also take A complement part. So what we'll do is we'll find out probability of A is equal to 1 minus probability of A complement. So A complement means we have to take opposite of what is said. So that is not pass through R will become pass through R. So through R, how many routes are there? 4 into 1 into 5, because we are making pass through R. That means it's 20. 20 upon 60. So that is 1 by 3. Now 1 minus 1 by 3 is 2 by 3, hence 2 by 3 is the answer. So there were two ways to solve this question. Now we can also consider individual probabilities. From B to C, we have to make not through R. So B to C, there are total 3 routes, but we just have to consider not through R part. Not through R means there are 2 routes. So 2 by 3 is the answer. Find the probability of going from A to D if you are allowed to use only routes I, J, Q, W, X, and Y. Now we just have to use I, J, Q, W, X, and Y. So let's focus on these routes only. So it will be ij, that is 2, into q, that is 1, into 3, that is w, x, and y. So it is 6. 6 upon 60, which is 1 by 10. So 1 by 10 is the answer. We can also solve this by using individual probabilities. So A to B, there are 2 routes out of 4. So it is going to be 2 by 4. B to C, 1 route out of 3. So 1 by 3. C to D, 3 routes out of 5. So 3 by 5. And it's a compulsion to travel from A to B, B to C, and C to D. That means A to B and B to C and C to D. So it is going to be 2 by 4 into 1 by 3 into 3 by 5, which is 1 by 10 again. Moving to the next question. Find the probability that February will have 5 Sundays. Now, we have to find the probability that February will have 5 Sundays. So how many days does February have? it will be either 20th or 29th. Now, 20th, in 20th, 5 Sundays won't be possible. So in 29 is the only possibility that we'll have 5 Sundays. But we don't know whether all the leap years have 5 Sundays or no. So 29 is going to be a leap year. So what do we have to find is we have to find the probability that it's a leap year and 1st of Feb is a Sunday. So probability of having a leap year is 1 by 4 because leap year comes once in 4 years. Probability that 1st Feb is a Sunday is going to be 1 by 7 because we want one Sunday out of 7 days. So 1 by 7. So 1 by 4 into 1 by 7, that's 1 by 28, which is the final answer. Moving to the next question. A committee of 5 members is to be formed out of 5 math faculty members, 4 verbal faculty members, and 10 students. What is the probability that the committee does not comprise of both verbal and math faculty at the same time? Now, what will be the sample space over here? So sample space is going to be 19C5 as there are 19 members and we have to form a committee of 5 members. So it is going to be 19C5. Now there are possibilities over here. So in this, there will be students or math, math verbal, math students, verbal students, math verbal students. But out of these possibilities, some of them will get eliminated as math and verbal cannot be together. So math verbal and math verbal student, this possibility will be eliminated. So these are the only set of possible favorable outcomes. Now it must have student math, math student, student only, verbal student, and only math. Over here, if you observe, these two things are counted twice. That is, SM and MS is counted twice. So, set of favorable events would be 15C5, because out of 15 members we are selecting 5, upon 19C5. Verbal students would be 14C5 upon 19C5. But we need to select, as it's or we will do plus, and we need to deselect the student part once, because if you observe the student part is counted twice. So what we'll do is, as S is counted in both, we will remove one S part. So let's remove one possibility, that is 10C5 upon 19C5, and that will give us the answer as the option first. So as the student possibility was counted twice, we removed first possibility. Moving to the next question. Committee of 5 members is to be formed out of 5 math faculty, 4 verbal, 10 students. What is the probability that committee has at least one student? Now, it is committee having at least one student. So let's take it as in a complement way. So complement means we will take opposite of what is asked. So it is going to be 1 minus probability of committee has no students. So it is going to be 1 minus committee having no student means we are just considering math and verbal for the 5 places. So it is going to be 9C5 upon 19C5. And to get the answer, it is going to be 1 minus 9C5 upon 19C5. Hence option 3 is the answer. Moving to the next question. A 5-digit number is to be formed out of digits 0, 2, 4, 5, 6, 7, and 8. What is the probability that the number formed will have 5 in the hundreds place? Now, in the hundreds place, we need 5. That means over here, nothing is said about repetition. So obviously we have to consider repetition allowed. Now only 5 can come at hundreds place. That means only one possibility would come. And for thousands, repetition is allowed. So 7 possibilities. For 10, 7 possibilities. For units, 7 possibilities. But for 10,000s, we have to consider 6 possibilities as 0 can't come. It's a 5-digit number. So 0 can't come, so 6 possibilities. In the sample space, again, it is going to be 7, 7, 7, 7, and 6, as the digits can repeat. And now we will eliminate all the common terms and we will be left with 1 by 7. So 1 by 7 is the answer. Now we can also focus and go with individual probabilities. So for individual probabilities, we will just use the 100 part. That's it. So at hundreds place, only one possibility could come out of 7 possibilities. So 1 upon 7 is the direct answer. Moving to the next question. 5-digit numbers have to be formed out of digits 0, 2, 4, 5, 6, 7, 8. What is the probability that number formed will not be divisible by 100? Not be divisible by 100. So let's take a complement part. That is 1 minus probability that the number is divisible by 100, because this one is much more easier to calculate. Now, for a number to be divisible by 100, the tens and the unit digits must be 0. So let's use individual probability. So only one digit can come at tens and one digit can come at units place out of 7 digits. So 1 by 7 into 1 by 7, that's 1 by 49, but it's 1 minus 1 by 49, which is 48 by 49. So 48 by 49 is the answer. Moving to the next question. 8 boys A to H have to be seated on 8 chairs. Find the probability that A and B always sit at the ends. Now A and B are sitting at the ends. That means these two places are fixed and we just need to arrange the middle 6 children. The middle 6 children. So 6 people can be arranged in a linear arrangement in 6 factorial ways. And A and B can also sit interchangeably, hence it is going to be into 2. So it is 2 into 6 factorial. Sample space is going to be all possible outcomes, that is 8 factorial. So 2 into 6 factorial upon 8 factorial, that is option 5 is the answer. Moving to the next question. Find the probability that only F sits between two other boys, G and H. So this means G, F, and H are always sitting together because F is sitting between G and H. So let us assume G, F, and H as one group and other as 5 individuals. That means we are arranging total of 6 entities now. We are arranging total 6 individual now because we have assumed G, F, and H as one entity. 6 entities can be arranged in 6 factorial ways, but G, F, and H can also be arranged among themselves. So they can be arranged in 3 factorial ways. That is, they can be arranged in 2 ways because F, the place is fixed. The position of F is fixed. That means we just have to arrange H and G. So H and G can be arranged in 2 ways. First way, it will be G, F, H. Second way, it will be H, F, G. So 6 factorial into 2 upon all possible outcomes is 8 factorial. Hence option 3 is the answer. Let's move to the next question now. From a normal pack of cards, 2 cards are drawn. Find the probability that one is a king and other is a queen if the 2 cards are drawn randomly. The 2 cards are drawn randomly. So this means choosing one king out of 4 and one queen out of 4. So that will be 4c1 into 4c1. It's a random part. That means we are choosing 2 cards together out of 52. So it is going to be 52c2. So option 1 is the answer to this question. Let's move to the next question now. From a normal pack of cards, 2 cards are drawn. Find the probability that one is a king, other is a queen. If 2 cards are drawn successively with replacement, it's with replacement. That means let us find out the probability that first card is queen, so which is going to be 4c1 upon 52c1. Let us find out it's with replacement. That means we will put the card of queen once again. Probability that second card is a king. So again, we are selecting one card out of 4 as its probability. Sample space is going to be 52c1. So it's 4c1 upon 52c1. In the middle, there will be a multiplication sign as we need to select both the cards, king and queen, and means multiplication. But over here, there's one more possibility that the first card could be queen, second king, and first card could be king, second queen. So that means we have just considered one possibility. To consider the next possibility, let us find probability that first card is a king. It will not change, it will remain 4c1 upon 52c1 into 4c1 upon 52c1. And it's or in between, hence plus will come. So it's basically 4c1 upon 52c1 into 4c1 upon 52c1 into 2, which is option 5. Let's move to the next question now. From a normal pack of cards, two cards are drawn. Find the probability that one is king, other is queen if the two cards are drawn successively without replacement. Now, it's without replacement means we are not putting the card again in the pack of cards. So, probability that first card is a queen is going to be 4c1 upon 52c1. So, it's without replacement. That means we don't have 52 cards now. We have only 51 cards. So probability that second card is a king is going to be 4c1 upon 51c1 and not 52c1 because we are not going to consider the card which we have removed. And there's into in between. Now, we have two possibilities, that is first king, second queen, and first queen and second king. That means we are simply going to do into 2 to it. Hence option 1 is going to be the final answer. Thank you.